Let's go ahead and take a look at our next example. This time we're being asked to factor x squared minus 16. Notice on this one we only have two terms, and this one is a difference of perfect squares. Right? X squared is a perfect square because x times x gives us x squared. 16 is a perfect square because 4 times 4 gives us 16. And we have a difference because we have the subtraction sign here in the middle. So whenever you're factoring a difference of perfect squares, you can go ahead and set up your two sets of parentheses. We'll take the square root of each of your terms. So our first slot is going to have an x in each one of those. And the square root of 16 will give us 4. And each of your parentheses will have one of each of the signs. One of them has to be a negative and one has to be a positive. The order itself doesn't matter on this one. Right, and so there is your factored form of this binomial. We can always check our work by multiplying it back out. We multiply x times x, we're going to get x squared. X times a positive 4 will give us a positive 4x. Our inside terms, if we multiply those, will give us a negative 4x. And our last terms here, negative 4 times positive 4, will give us a negative 16. Right, we can combine our like terms there in the middle. These are going to add up to be 0. So we'll end up with x squared minus 16, which is what we started with. So this will be our factored form of that binomial. Let's go ahead and take a look at part B. This time you'll notice it's a little bit different. We've got x squared plus 16. So we do have perfect squares with the x squared and the 16. However, we have a positive sign there between the two. So this is not something that we can factor, right? It's not a difference of perfect squares. It's not a subtraction sign there. So this one is actually considered to be prime. Prime is another word for a problem where we're not able to factor it. Let's take a look at our next set of questions. This is similar to our last example. However, this time we're being asked to solve each equation. You'll notice that each of these has the equals 0 written after them. So when we're solving these, we want to solve for our variable, which in this case would be the x. And similar to our last batch of examples, our first step is to factor. Okay, so in our last example, we factored the x squared minus 16 into x minus 4 and x plus 4. We'll make sure we still set this equal to 0. Okay, remember that the only way you can have an answer that's equal to 0 is if one of those factors equals 0 itself. So we'll take each set of parentheses and set that equal to 0. And then we can go ahead and solve each equation, right? We can add 4 to both sides on this one, and we'll get an x value of 4. And if we subtract 4 from both sides on the second one, we'll get an x value of negative 4. Alright, so we have two answers to this equation. We have x equals both a positive and a negative. Let's go ahead and take a look at part B. Remember, this is one that we were not able to factor last time, right? This was a prime binomial that we had, that x squared plus 16. So if we want to try and solve this where it's equal to 0, it is possible. We're just going to end up with some imaginary numbers along the way. So we know we're not able to factor this, so let's go ahead and try to subtract 16 from both sides. Now notice you've got x squared equals negative 16. You know when you go to square a number, you're not able to get a negative, so if we want to undo that squared part, yes, we can go ahead and take the square root. However, we're going to be taking the square root of a negative number. So let's go ahead and take a look at what happens here. When we take the square root of x squared, that's going to give us an x. And when we take the square root of negative 16, if you try to type this into your calculator, it's going to give you an error. Okay, but we can actually do this where we're working with imaginary numbers. Right? Keep in mind you can break this apart into the square root of a positive 16 times the square root of a negative 1. And the square root of negative 1 is an imaginary number. We usually use the letter I to represent that imaginary number. And when you go to take the square root of 16, you'll get both a positive and a negative 4. So we end up with two answers here, both a positive and a negative 4i. Those would be imaginary numbers because it has the I attached to it. And let's go ahead back and take a look at a second example here with these same two equations. Let's just do part B on this one. I'll show you a second way you could solve this equation. Okay, on the last one, we went ahead and subtracted the 16 from both sides. On this example, let's go ahead and use the quadratic formula. And if it's been a while, we have x equals negative b plus or minus the square root of b squared minus 4ac. All of this over 2a. Keep in mind with your quadratics, they are in the form ax squared plus bx plus c. So if we're looking at part B on this one, our a value is a 1, since it's in front of the x squared term. Our b value is 0, since we don't have any x terms in our equation, and our c value is going to be a positive 16. So let's go ahead and use the quadratic formula to get our solutions for this one. We have a negative b value, which in this case would be a negative 0. We don't necessarily have to write it if we're plugging in 0 there. So we'll continue on with our equation. We've got plus or minus b squared would be 0 squared minus 4 times 1 times 16. And all of this would be over 2 times 1. So let's go ahead and simplify what we have underneath the radical. If we multiply the negative 4 times the 16, we're going to get a negative 64. All of this will be over 2. And keep in mind we could do the same thing with that negative 64. We can break this apart into the square root of 64 and the square root of negative 1. So this will give us a positive and a negative 8i all over 2. And we can go ahead and reduce this, right? 8 divided by 2 is going to give us 4. So our final answer here will be x equals positive and a negative 4i, right? Which is the same answer we had when we went ahead and subtracted the 16 from both sides. So it doesn't necessarily matter which way you approach this problem, you should still end up with the same solution.